Hi, we're looking at cleavage this morning in an effort to help you with your lab. So minerals have a natural breaking pattern sometimes, and that breaking pattern is referred to as their cleavage. If you have a mineral like mica, this is a fairly thick piece of mica, it can be separated or split apart into thinner sheets, usually with your fingernail or sometimes a thin-bladed knife. And what you end up with are pieces that look like this. They're flat and shiny, and you can see you can separate off the little piece into much thinner sheets. These sheets are so thin you can see through them. Again, it's one plane of cleavage because they stack up like pages in a book or like pages in some sort of a tablet. So one plane of cleavage. There are two kinds of mica that are fairly common, biotite and muscovite, and you distinguish them by their colors. You'll be able to look that up in the chart. Another mineral with only one plane of cleavage is gypsum. This is a section of gypsum. Gypsum sometimes is very flat, and when you pop it apart, you get these fatter little pieces, these tabular shapes. So it's much thicker than the little sheets you get when you separate the micas, the muscovite or the biotite. So it's an easy way to tell them apart. Gypsum also sometimes appears as different shaped crystals. This one has a radiating pattern that comes out of it, almost like it's trying to make little flower shapes to it. Or sometimes gypsum looks like these interwoven crystals, and occasionally it will make a rosette shape. This is not a gypsum rosette. This is a barite rosette. The petals are a little too thick to be the gypsum, and it weighs too much. It's too heavy. So other minerals can have cleavage. This is a halite crystal. Halite is the mineral name for salt. If you looked at salt from a salt shaker under a magnifying lens, it would look a lot like this. If you found a sharp corner and you looked at the 1, 2, 3 planes that come together and meet at that sharp corner, you would see that there are 3 planes of cleavage associated with halite. They meet at a 90-degree angle. I can set it down on the street plate and you can see that it lines up. An easy way to tell halite from other minerals is to taste it. You can lick it, or you can lick your finger, touch the rock, put your finger back to your tongue, and taste the salt that way. So halite. Another mineral with 3 planes of cleavage is calcite. So calcite, again, if you found a corner, you'd find 1, 2, 3 planes of cleavage all coming together at that one corner. The difference with calcite, though, is that it does not form a 90-degree angle. You can see fairly obviously here that it's tilted when you look at it. Maybe if I put it against the blue, you can see that it's at an angle. So calcite does not form a 90-degree angle. If you happen to get lucky and have a clear crystal of calcite, again, an easy way to tell it from the halite is to lick it. But another way is that the clear form of calcite, which is called Icelandic spar, if you put it over a bit of typing or writing, it has a property called birefringence, and you end up with a double image when you look through if the crystal is thick enough. So Icelandic spar is a variety of calcite. Let's see. There are some minerals. Here is a piece of galena. Galena is a mineral with 3 planes of cleavage. If you found a corner, you'd find 1, 2, 3 planes that come together at this point. What's interesting about the galena is that oftentimes little bits of it chip off and you can see the substructure. So it's like it's made out of hundreds of little boxes all stacked together, kind of like a Lego mineral, if you will. This is galena. This is the mineral fluorite. Fluorite comes in a variety of really pretty colors. Some of it is green, some of it is lavender. Sometimes you see the octahedral crystal shape, and sometimes you don't. This one, if you looked at it and could see it closely enough, has a cubic crystal shape to it. Whether it forms the 8-sided crystal shape or the eight-pointed crystal, the octahedral, or the rectangular, the cubic ones, depends on the temperature that it forms at. So different colors, it comes in yellow and green and pale blue. A lot of times people will describe fluorite as looking like colored ice. It has a very translucent quality to it, and I find that an apt description. It's hard to sometimes see the cleavage in fluorite. A mineral that's oftentimes confused with fluorite is quartz. Quartz does not show cleavage. Quartz makes crystals. Here's a fairly large quartz crystal. Here's a smaller one that you can see. But it's also fairly common, instead of seeing the crystal form, to see the amorphous form. And in that you can see that the quartz, when it breaks, forms what's called conchoidal fracture. So that's a wavy nature to the fracture. It does not form a repeated pattern that you can get over and over again. But again, it's a wavy nature. Quartz comes in different colors. This is a piece of smoky quartz. The different colors are a result of different impurities. Smoky quartz has aluminum in it. If I had a piece of purple quartz, it would be amethyst. Amethyst has iron impurities in it. If it were pink quartz, it would be called rose quartz, and the colors are a result of either titanium or iron or manganese in it. So a lot of different things can give it that unique color. Some minerals have cleavage, but it's next to impossible to see it. This is a piece of dolomite, and it's supposed to have 3 planes of cleavage, but I think you would be challenged in a piece this small to identify it. So sometimes it's very easy, like with the calcite. Sometimes it's very difficult, as in the dolomite. So you use it when you can, but it's not always very apparent. I hope this helps you with your lesson.